Hello again. We continue with section 4. In this case, we are going to deal with wave reflection. To approach this study, we will introduce the phenomenon of reflection. Then we will formulate it mathematically, and then we will see the many applications that in our daily life has this phenomenon. When we have a wave that arrives or meets a medium or an interface between two different media, in general, we will have a wave that is reflected and a wave that is refracted. We can talk about waves or we can talk about rays, as we have seen in the previous lesson. Well, if we have an incident ray, when it finds the separation between two media, both phenomena, both reflection and refraction, what they cause is a change of direction of the incident wave. The reflected ray returns to the same medium with that change of direction, while the refracted ray propagates, the new ray propagates in a different medium. If we were now to have another interface, i.e., a change of medium, again, we would again have the same phenomenon. We would again have a reflected ray that would return to medium 2 and a refracted ray that would pass to medium 3. Well, so let's look at the phenomenon of reflection. It turns out that Amanda has gone on a hike, and when she gets home, she looks at the picture. She was lying down and saw the trees. When she gets home, what she realizes is that everything she was seeing while she was lying down is now also reflected in the water. What has happened? Again, she sees another photo. And in this one, she also sees a phenomenon, a similar image. However, now the image is blurred, with less sharpness. And she wonders what the difference is if the day was the same. And apparently everything was the same. Well, the difference is that now the seawater is not a flat surface because the water is flowing, and therefore the reflection of the waves, because as you can imagine, the responsible for all this is the phenomenon of reflection. The reflection of the waves does not occur in a clean way, we could say. Being in motion, the reflection is more random, and this causes the image to be blurred as seen through a fogged glass. Well, let's get serious about the phenomenon of reflection. Reflection is a change of direction when a wave strikes the boundary between two surfaces, between two different media. After reflection, the wave will continue to propagate in the same medium. We have an incident wave that the angle of incidence is the angle formed by this wave or this ray with the normal to the point of incidence, the normal to the surface at the point of incidence. Once it is incident, reflection occurs and the ray propagates again through the same medium. The angle formed by the perpendicular at the point of incidence, the perpendicular to the surface at the point of incidence with the reflected ray, is the angle of reflection. Well, let us suppose that we have a wave front. And at point A, the first ray of that wave front arrives. At point B, we will have another ray that will be occupying that position. As we have already said, the angle of incidence is that which forms the ray that we have taken, that one, because it is in which that instant has arrived, is that which forms the ray with the normal to the surface at the point of impact. The wave front would be constituted by this line. And time must elapse so that point B reaches point D. Well, if we look at this triangle, this new angle, this one that you see here, is also angle I. Okay, by triangle similarity. Well, when point B reaches point D, what happens? Point A has already evolved, the reflection of the wave has already taken place, and point A would occupy point C. The new wave front would be this one that we have marked. It would be the wave front at the instant in which the point that occupies a position B has reached the separation surface. At that instant, the point B has already evolved. Now we would have the angle of reflection, which, as we have already indicated, is that which forms the refracted ray with the normal to the surface at the point of incidence, and by similarity of triangles would also be this one here. Well, let's analyze this in terms of Huygens principle. When point B arrives at D, a certain amount of time has passed with respect to the instant at which it had reached A. Then the wave has propagated, and this secondary wave that Huygens' principle told us would be this one that we have on the screen. Any other intermediate point would be the same, and therefore the envelope to these would be the new wavefront, which is the one we had marked. As you can see, Huygens' principle allows us to explain the phenomenon of reflection. Let's see. Well, these are the angles of reflection that we had already indicated. Let's see how we can mathematically express the angles of incidence and reflection angles. If we look at the triangle ABD, we can express that the sin of I is BD. This slice divided by AD, which is this slice here that would constitute the hypotenuse. BD is a space taken by the velocity of the medium times the time that has elapsed. VT divided by AD. If we want to express the sine of the angle of reflection, sine of R, we have to look at the triangle ACD. What is AC? AC is the space that the reflected wave has traveled in time t, which is the same time we had up here. As the medium of incidence and reflection is the same, the velocity of propagation will be the same v. And therefore the sine of R will be AC divided by BD equal to VT divided by AD. If we compare the sine of I with the sine of R, this term is equal to this, and therefore the sine of angle I is equal to the sine of angle R, which leads us to the angle of incidence is equal to the angle of reflection. So, what are the laws of reflection? We have already seen them. The laws of reflection are that the angle of incidence denoted by I, the reflected angle denoted by R, and the perpendicular to the surface of the medium at the point of incidence are in the same plane. And the second law is that the angle of incidence and the reflected angle are equal. So, going back to Amanda's image, how do we explain it? Or how can you explain what happened? Well, what happened is going to be given to you by J. We have a direct wave, but apart from this direct wave, we also have the reflected wave. And the reflected wave is what makes us see an inverted equal image, as it appears on the screen, which is what happened to Amanda. Well, having seen this, we are going to see the applications and related topics. First of all, we can point out the echo. The echo is used both by animals as well as radars. It consists in the transmission in the air. There is a reflection, and then that will give us information about where the different objects are located. Also sonar, which is the same phenomenon, but in water. It will be valid for both animals and ships, for example. What else? Periscope, which uses the theme of mirrors, and laser readers, which can be used, for example, in barcodes or compact discs, and also in parabolic reflectors. In these, starting from a wave, a beam of waves reflecting in the parabola makes all that information or all that wave to fall on a point, precisely on the focus. We know, as you have seen in previous lessons, that parabolic screens are based on this principle. Well, what have we studied today? we have seen the phenomenon of reflection, we have formulated it mathematically, and we have seen its applications. That's all. See you in the next lesson.